Good day viewers, wherever you are watching this video from, I welcome you to our session for physics, even as we look at the topic that we call electricity. Electricity is one of vital topics in our physics that does not miss year in, year out. Either the paper is for GC or the paper is for what? Internal. And you need to prepare a lot about it because there are so many questions that are asked both in multiple choice section B and section C of your paper. Now, before we go to solve the questions that are on the board here, I want to show you a few things that you need to take note. We have a diagram here, which we call a circuit diagram. But before we come to the questions, I want to show you on how you can solve questions in series and as well as in parallel. So I'm going to start with the parallel here. I'm going to start with the parallel. So for parallel, okay, so I'm going to show you the things that we need to take note when you are dealing with the series circuit and as well when you are dealing with the parallel. Your circuit can either be in series or it can either be in parallel, or they can combine both. For example, whatever you have seen there is a combination of of series and both parallel. So we are going to start with parallel. Number one point that you need to know is the formula that we use to find the effective resistance. So effective resistance in parallel or total resistance is R1 times R2 over R1 plus what? R2. If you have R3 here, there is no problem. There is no problem as well. Then here we also add what? R3 like that. Okay? That is the formula. Even if there are four, all the same, you are going to use the same formula. Number two, the point that you need to know is that voltage is the same. Voltage is the same at all points. Voltage is the same at what? All points. Meaning, when we come to our diagram here, this voltage 20 is the same everywhere as long as it is in parallel. So this one and this one, they have the same what? Voltage. Then number three, we are going to say that current is different. Current is different at all points. Current is what? Different. But when we come for series here, when we come for series, it is the opposite of whatever that we have written here. The formula that we use to find the R total, it is R1 plus R2. If we have R3, then we are going to add what? R3. Here we are multiplying. Here we are just what? Adding. That's the first point. The second point is that current is the same in the series. Current is what? Is the same. At all points, it is the same. Then voltage is different. Voltage is what? Different. On parallel here or in parallel, we say the voltage is the same at all points, but the current is different. Therefore, if you want to find total current here, you add the R1 plus what? I1 plus R2, I2. But on the other side, if you want to find the voltage, you need to add the V1 plus what? V2. Then you're going to find your total what? Your total voltage. Now, without this info here, it will be very difficult for you to solve any questions that come under electricity. So, this information is very vital. Okay, shall we go into our solvings now? Okay. So now, let's solve the first question. What is the effective resistance of the circuit? Effective resistance of the circuit. The keyword there, it is the resistance there. So a device that measures resistance is what we call a resistor. A resistor is a device that measures what? Resistance, and it is given by this symbol there. Okay, that's a symbol for resistance. Then we have what we call a rheostat. A rheostat that has this symbol. Okay, it has this symbol. This is the one that can measure what we call variable resistance. We call it as a rheostat like that. That is the name of that. So resistance, this is the opposition to the flow of current. Resistance, this is the opposition to the flow of current. Usually, current will move from the positive going to the what? To the negative. This is the direction for current. So if current is moving in this direction, it means that the resistance is moving in the opposite what? Direction. Now, for you to measure total resistance, this word effective may also mean total resistance. So in case you find the total, in case you find effective, it is just one and the same thing. So you need to check your arrangement of your resistance. There are these two that are in parallel. Parallel lines, mathematically we know to say these are lines that do not meet. So this is opposite to this, or it is parallel to that. There is this resistor which is in what? Series. Allow me to say this is the R1, this is the R2, and this is what? R3. Okay? So to find effective resistance here, we will be required to find the first the resistance that are in parallel, then we add that is which in what? In series. So our total resistance there, A, will be equal to, we are going to multiply R2 times what? R3 over R2 plus what? R3 like that. Okay? So what do we have there? We have 2 times what? 2 times 2 over 2 plus what? 2. Okay? We have R2 and R3. So 2 times 2, what we are getting is what? Is 4. And 2 plus 2 again we are getting what? 4. It means that the total resistance for parallel only, we are getting as what? As 1 ohm. But this is not the answer. When we combine these two, okay, we are getting the answer as 1 ohm. But since the question is saying we should find the total resistance, we need to add now R total, this one which we have found here, and this one which is in the series, which is 3. So we are going to add the R1 plus the one that we have gotten from what? From this. And we are going to get 3 plus what? 1. And this is going to give us what? 4 ohm. Meaning the total resistance of the entire circuit, it is 4 ohms, and you get your answer. Just this. That's your A. We go to B, unless if there are questions, unless if you haven't understood the part here. For B, we have been told to calculate the current that flows in the what? In the battery. Now, for current here, with our data that we have, we are going to use this formula for Ohm's law. We are going to use this formula for Ohm's law. You need to know what Ohm's law is, okay? You need to know the law by all means, because it is very, very effective. So, we need to find this I. We have voltage which is 20, we have resistance which is 4, so we can find what? I. So we say over 1 there. So we are going to say I is equals to V over what? Over R like that. What is our V? It is 20. What is our R? We have found what? 4. When we divide there, we are getting 5 what? Amps. You know that current, this is just the flow of electron in a circuit. Current, by definition, or electrical current, this is the flow of electrons in a circuit. Remember, there is static electricity and the electrical current. Statical electricity is where we are dealing with charges, those that are positive and those that are negative. But electrical current, this is just the flow of electrons in a conductor. Then this current is always given in amps. Is always given in what? In amps. And the instrument that measures this current is what we call the ammeter. This which is here, the ammeter. It is the one that measures what? Current. To be specific, this ammeter, if you have seen here, it is connected in series. That is the difference that is there between the ammeter and the voltmeter. The ammeter is connected in series and the voltmeter is usually connected in parallel. Are we together? And the the ammeter measures current, the voltmeter measures what? Voltage. So this is the current that we have there. Okay? Having found this, we can now determine the charge. We can now determine the what? The charge. We can now determine the charge. Okay, now we are right here on question C, where we will need to find the charge flowing through the battery in 1 minute. Now, the formula for charge, it is Q is equals to IT. Q is equals to what? To IT. So we want to find this, okay? Now, this T, it is always given in seconds, not minutes, but seconds, and not in hours. Then the I, it stands for what? For current. If you remember, on question B here, we have found the resistor which is 4 ohm, and we have also found the current which is what? 5 amps there. So, the current we have, and we have been given that we should find the charge flowing through the battery in 1 minute. In 1 minute, there are 60 seconds. In 1 minute, there are 60 seconds. So what are we going to do there? What are we going to do? So since we have the formula already, we are going to say our current was 5. We are going to convert that 1 minute. 1 minute is equal to what? 60 what? Seconds. So we are going to put 60 there. If we multiply there, 5 times 60, I'm getting an answer which is what? 300. The units for charge are the coulombs. The units for charge are the coulombs. But there are situations where they can give you charge and they give you current, then they ask you to find the time. Any of the two. They give you charge and the current, then they ask you to find what? Time. Then let's go to question D. Question D is saying we should calculate the energy costs of the 3 resistors. If these resistors were used for 40 days, for 4 days, we should calculate the what? The energy what? Costs. Allow me to lab this. Now, the formula that we use to find energy cost is E is equals to PT. E is equals to what? PT. This E stands for energy costs. This is for power. Then this is what? Time. So the first thing that we need to do, we need to find the power. Power is the ability to do work. And the power is given by the formula V times what? I. Okay? So our voltage we have 20. Our current we have what? 5. We are going to get 100 watts. Okay? That's what we are getting. Power is always given in what? In watts. But when we come here, when we are finding energy costs, this power, it has to be in kilowatt. It has to be in kilowatt. So we need to convert this 100 watts. We take it into kilowatt. So 1 kilowatt is equivalent to 1000 watts. So since we have 100 here, watts, it means we put x. It means we are going to say 100 we divide with what? 1000, and we are going to get that this power, it is 0.1 kilowatt. Okay? Then times. Now, when we come to the time, we have been given 4 days. We have been given what? 4 days. We know that in a day, there are 24 hours. In a day, there is 24 hours. And these resistors were used for how many days? 4 days. Meaning I'm going to multiply 24, we multiply with 4. We are going to get 96. It means that these 3 resistors were used for 96 hours. So I'm going to bring 96 like that. And I'm going to multiply there with 96. I'm getting an answer if I multiply 0.1 times 96. I'm getting an answer which is 9.6 kilowatt hour. That is the energy that was used, or those were the units that they these three resistance that they used for what? For 4 days. When you go on your meter box, you find this. If you have 100 units, it will be written 100 kilowatt hour. That's what we call 100 units. And that is how you go about those questions. But mostly in paper 1 questions, in science 1 on multiple choice, there are questions where they have given you the units. Let's say they tell you to say if 1 unit is costing 2 kwacha 50 ngwe. If 1 unit is costing 2 kwacha 50 ngwe, that is per unit. Then you have found 99.6 units. How much will these units cost? Such kind of questions also they are there. It means when you reach here, you are going to multiply the 9.6. You are going to say 9.6 times that. So 9.6 you multiply with 2 kwacha 50 ngwe. It means that these 9.6 units were costing what? 24 kwacha. We are costing 24 kwacha. And such type of questions are very common in the exam. Electricity is a topic that you can't afford to miss if you are preparing for physics. And this is just a build-up, or those are the many topics that you have to know in physics before you sit for exams, because in any exam you have questions that are like this. Unless if there are questions, but that is how best we can explain. If there are questions, you can write there or ask in the comment section there. I want to give you one question that you are going to try as well. I see if you are going to get.